Hello, my name is Lindsay, and today I'll be going over the feedback loops in the non-gravid female reproductive system. In the non-gravid female reproductive system, females produce eggs in monthly cycles on an average of every 28 days. These cycles are commonly called menstrual cycles because there is a 3 to 7 day period of the bloody uterine discharge known as menstruation. The menstrual cycle can be described by the following changes that occur in follicles of the ovary known as the ovarian cycle, or by the following changes in the endometrial lining of the uterus known as the uterine cycle. The ovarian cycle is divided into 3 phases: the follicular phase, ovulation, and luteal phase. The first part of the ovarian cycle, known as the follicular phase, is a period of follicular growth in the ovary. This phase is the most variable in length and lasts from 10 to 21 days. Once one or more follicles have ripened, the ovary releases the oocyte or cytes during ovulation. The phase of the ovarian cycle following ovulation is known as the luteal phase, which is the transformation of a ruptured follicle into a corpus luteum. The corpus luteum ceases to function after about 2 weeks, and the ovarian cycle begins again. The endometrial lining of the uterus also goes through a cycle. The uterine cycle is regulated by ovarian hormones. The beginning of the follicular phase in the ovary corresponds to menstrual bleeding from the uterus known as the menses. The latter part of the ovary's follicular phase corresponds to the proliferative phase in the uterus, during which the endometrium adds a new layer of cells in anticipation of pregnancy. After ovulation, hormones from the corpus luteum convert the thickened endometrium into a secretory structure. This means that the luteal phase of the ovarian cycle corresponds to the secretory phase of the uterine cycle. If no pregnancy occurs, the superficial layers of the secretory endometrium are lost during menstruation as the uterine cycle begins again. The first day of menstruation is day 1 of the cycle, because this is the easiest observed physical sign. Right before the beginning of each cycle, gonadotropin-releasing hormone, known as GnRH, is secreted from the hypothalamus and triggers an increase in follicle-stimulating hormone, known as FSH, and luteinizing hormone, LH, from the anterior pituitary gland. Under the influence of FSH, a group of tertiary follicles in the ovaries begins to mature. As the follicles grow, their granulosa cells, which is under the influence of FSH, and their thecal cells, which is under the influence of LH, start to produce steroid hormones. The granulosa cells also begin to secrete anti-Müllerian hormone, AMH, which decreases the follicle sensitivity to FSH, thus preventing recruitment of additional follicles once one group has started developing. Thecal cells synthesize androgens that diffuse into neighboring granulosa cells, where aromatase converts them to estrogens. This gradual increase of estrogen in the circulation has many effects. Estrogen exerts negative feedback on pituitary FSH and LH secretion, thus preventing the development of additional follicles in the same cycle. At the same time, estrogen stimulates additional estrogen production by the granulosa cells, which is a positive feedback loop that allows follicles to continue estrogen production even though FSH and LH decrease. Menstruation ends in the uterus during the early follicular phase. Under the influence of estrogen from the follicles, the endometrium begins to grow. This increases blood supply, which brings more nutrients and oxygen to the thickening endometrium. Estrogen also causes the mucus glands of the cervix to produce watery, clear mucus. Ovarian estrogen secretion peaks as the follicular phase nears its end. Only one follicle is still developing by this phase of the cycle. Granulosa cells of the dominant follicle begin to secrete inhibin and progesterone in addition to estrogen as the follicular phase ends. Estrogen changes to a positive feedback effect on GnRH rather than a negative feedback seen earlier in the follicular phase. This change to a positive feedback leads to a pre-ovulatory GnRH surge. Right before ovulation, persistent high levels of estrogen, along with the help by rising levels of progesterone, enhances pituitary response to GnRH. This causes LH secretion to increase dramatically, which is known as the LH surge. FSH surges also, but to a lesser degree. This is because FSH is suppressed by inhibin and estrogen. The LH surge is an important part of ovulation because it causes secretion of many chemical signals that are needed for the final steps of oocyte maturation. Meiosis resumes in the developing follicle with the first meiotic division. This divides the primary oocyte into the secondary oocyte. While this division takes place, antral fluid collects and the follicle grows to its largest size, which is the follicle preparing to release the egg. High levels of estrogen in the late follicular phase prepare uterus for a possible pregnancy. Just before ovulation, the endometrium grows thick, and the cervical glands produce a ton of thin mucus to help with sperm entry in the stages set for ovulation. 16 to 24 hours after LH peaks, ovulation occurs. The mature follicle secretes prostaglandins and proteolytic enzymes that dissolve collagen and other connective tissue, holding follicular cells together, which contributes to the follicle wall rupturing. Antral fluid spurts out along the egg, and the egg is swept into the fallopian tube and carried away to be fertilized or die. After ovulation, follicular thecal cells migrate into the antral space, which mingle with former granulosa cells and filling the cavity. Both cell types transform into luteal cells of the corpus luteum, which is known as luteinization. The new luteal cells accumulate lipid droplets and glycogen granules in their cytoplasm and secrete hormones. As the luteal phase progresses, the corpus luteum produces steadily increased amounts of progesterone, estrogen, and inhibin. Progesterone is the dominant hormone of the luteal phase. Estrogen synthesis decreases initially, then increases, but never to the peak levels that are seen right before ovulation. The combo of estrogen and progesterone exerts negative feedback on the hypothalamus and anterior pituitary, resulting in suppression of GnRH, FSH, and LH. Luteal inhibin production further suppresses LH and FSH, which remains shut down through most of the luteal phase. The endometrium continues its prep for pregnancy due to progesterone, and the endometrium becomes a secretory structure. The glands of the endometrium coil and additional blood vessels grow into the connective tissue layer. Endometrial cells deposit lipids and glycogen in their cytoplasm, which provides nourishment for a developing embryo. Progesterone also causes the cervical mucus to thicken, which creates a plug that blocks the cervical opening, preventing bacteria as well as sperm from entering the uterus. The corpus luteum has a lifespan of about 12 days. If the pregnancy does not occur, the corpus luteum will undergo apoptosis. Progesterone and estrogen production decrease as the luteal cells degenerate. This decrease of progesterone and estrogen removes the negative feedback signal to the pituitary and hypothalamus. Thus, secretion of FSH and LH increases. When corpus luteum degenerates and hormone production decreases, the blood vessels in the surface layer of the endometrium contract. Without oxygen and nutrients, the surface cells die, and about 2 days after the corpus luteum ceases to function, the endometrium begins to slough its surface layer and menstruation begins. Menstruation continues for 3 to 7 days well into the follicular phase of the next ovulatory cycle. In summary, eggs are produced in monthly menstrual cycles. In the ovarian cycle, the follicular phase is a period of follicular growth. The follicular granulosa cells secrete estrogen, and a surge of LH is necessary for oocyte maturation. Ovulation is the release of an egg from its follicle. In the luteal phase, the ruptured follicle becomes the corpus luteum, which secretes progesterone and some estrogen, which causes negative feedback on the hypothalamus and anterior pituitary. The menses begin the uterine cycle, which is followed by the proliferative phase with endometrial thickening. Following ovulation, endometrium goes into a secretory phase. And this concludes my presentation. Thank you for listening, and here is my citation.